objective. Use simple collision theory to explain the effects of concentration, temperature, and particle size and the rate of reaction.
Hi, Grade 12 students! Are you ready to learn something new today? I'm Teacher Diane, your physical science teacher. Before anything else, please get your module and turn it to page 40. Alright, let's begin!
What does the following have in common? Rusty nail, change in color of leaves, and bleached hair. You have 5 seconds to answer. Time starts now. That's right. They all undergo chemical reaction. A chemical reaction is a process through which one or more substances are changed into different substances. Just like this iron nail turning into a rusty nail. The original substances are called reactants. The resulting substances are referred to as products. On the example shown, we have oxygen, iron, and water as the reactants. When combined together, iron will turn into rust, and this becomes the product. A chemical reaction can be better understood by considering it as a process involving collisions between reacting particles. Here, we have 2 particles on each side. When these 2 particles collide, it will undergo chemical reaction. Observe the resulting product. From 1 chlorine and nitrile chloride, it turned into 2 chlorine and nitric oxide. In order for chemical reaction to take place, there should be collision between reacting particles. Collision theory states that reactant particles requires sufficient kinetic energy to initiate successful collisions that will lead to the formation of products. But what if there is not enough kinetic energy? There will be ineffective collision. Observe the 2 particles below. Is there a change of particles before and after collision? No. That is why kinetic energy is needed for an effective collision that will lead to a chemical reaction. Let us now proceed to the rate of reaction. Rate of reaction is the speed by which reactants are converted to products. A reaction that takes a long time to complete is described to have a low reaction rate. A reaction that occurs quickly has a higher reaction rate. A reaction can be speeded up or slowed down by manipulating many different factors, which include concentration, particle size of reactants, and temperature of the reaction. Let's take a look on these 2 sets. Which of the 2 do you think will have a faster reaction rate? You have 5 seconds to answer. If you answer set B, you are right. Very good. Here, we have few molecules. Chances of particles colliding with each other is low. Therefore, the rate of reaction is low. Here, we have many molecules. chances of particles colliding with each other is high. Therefore, the rate of reaction is greater. This is what we call the effect of concentration. If there is a higher concentration of one or more of the reactants, there is a greater chance that collisions will occur among particles of the reactants. More collisions mean a faster reaction rate. This explains why wood burns much faster with pure oxygen that has 100% concentration than in air, which has only 21% oxygen composition. That is why people are not allowed to smoke near an oxygen tank. Let's take a look on this another set. Which of the two sets do you think will have a faster reaction rate when burned? You have 5 seconds to answer. If you answer set A, you are right. Good job! This is what we called the effect of particle size. Reactant particles with same phase, liquid to liquid or gas to gas, may easily mix with each other. This gives the particles the maximum opportunity to collide and react. The case is different when one of the reactants is a solid, just like on the example earlier with the wood. The reaction can only take place on the surface of the solid. The smaller the size of the solid particles, the greater is the area in which the reaction can take place. To illustrate, when one reactant is in solid pieces, the other reaction can only occur at the surface. If the solid pieces are subdivided, there is more surface area and more collisions per unit time. Therefore, the reaction occurs faster. We have another set. On the left corner, we have particles under high temperature, and on the right, we have particles under low temperature. Take note that the arrow signifies the speed of the particles. Which of the two sets do you think will have a faster reaction rate? You have 5 seconds to answer. If you answer high temperature, you are correct. Great job! Effect of temperature. When the reaction temperature goes up, the reaction rate increases as well. The average kinetic energy of particles increases with rising temperature, which means that at higher temperatures, particles tend to move faster. Consequently, more effective collisions are favored. Now, I will show you a video clip on the effects of temperature on reaction rate in real life.
Doble ingat po sa paghanda ng pagkain lalo't madali itong mapanis ngayong tag-init. Sa ilang lugar nga, marami nagkakasakit sa tiyan, madalas pa ay mga bata. May report si Susan Enriquez.
Nasa 10 pasyente kada araw na karamihan ay bata ang dinadala sa Abra Provincial Hospital sa Bangged, Abra. Kaya siksikan sa pedia ward ang mga nakakonfine. Karamihan sa kanila ay acute gastroenteritis o stomach flu. Ang 5 taong gulang na batang 4 na araw na nakakonfine, nagsusuka at may pagdudumi.
Siguro dahil sa weather related to itong init ng panahon, syempre yung mga pagkain madaling mapanis.
Foods spoil easily when left at room temperature, but they last longer when placed inside a refrigerator or freezer. The chemical reactions causing the spoilage are slowed down at lower temperature.
That's it for our discussion. Now, let's do a recap by answering the table that will be flashed on the screen.
In the first column, we have the factors: concentration, particle size, and temperature. On the second column, we have the effect on reaction rate if factor is decreased. And in the last column, we have the effect on reaction rate if factor is increased. Let's begin. What will be the effect on reaction rate if concentration is decreased? The reaction rate will also decrease. And what will be the effect on reaction rate if concentration is increased? It will also increase. Next, let's proceed to particle size. What is the effect on reaction rate if particle size is decreased? It will increase. And what is the effect on reaction rate if particle size is increased? It will decrease. And lastly, we have the temperature. What is the effect on reaction rate if temperature is decreased? It will also decrease. And what is the effect on reaction rate if temperature is increased? It will also increase. If your answers are correct, very good.
I hope you learned something today. Before we end, I want you to answer the assessment on your module on page 43. If you have questions, don't hesitate to reach me through Messenger. That's it for today. Till next time, happy learning everyone!
This video is brought to you by Department of Education, Division of Piliran, Naval Knight High School, Care Lampara Program, TV.